Hello, my name is Henry, and this is my presentation video for the Capstone defense. First of all, I want to apologize for our misunderstanding of the rubrics for the Capstone rubrics. And also, I want to say a big thank you for giving us opportunity to add up on the work that we did throughout the 2 semesters and finish our project. So I will focus on the enrichment engine pipeline, which I worked on here. And to start, I think I will show you the dataset that I used. So the one dataset I found, which was very convenient to use, is this one. It has images like this with different items, and also it has a CSV file for styles, so they are mapped by ID, and the dataset has gender, multi-category, subcategory, article type, base color, season, year, usage, or display name. I will go over this again later, but overall this dataset is what I used for my models. So let's come here, and this is a sequence diagram how I train my models. So basically I load dataset, then remove unnecessary columns. I rename categories to match the categories in my DB in Fitfolio. Then I do the same with gender to match my database, and also I map all the colors to 12 colors that I have in Fitfolio. I verify the category distributions. Then I map the item descriptions with images. I remove items with no images. I convert string labels to integer class IDs, and then I split data into train and test splits. I used 4 models. I trained 4 models, and then I compared the results and chose the best model. So this is the diagram for training, and the use case diagram, sequence diagram, it's basically when users submit image of the item in the add form on the website. Java Spring Boot gets the image, it calls the machine learning fast API service. That one runs the enrichment pipeline, then which removes the background. Then it validates if the image is the image of the item, or maybe it's image of the animal, and then it will reject it. Then classify image, get meta tags from OpenAI. I also did some tests. Validate enrichment, and return to Java and save item database. Basically, this is the sequence diagrams that I have here, and now let's discuss it better in the Python. So let's go to the code, and initially I created a Python notebook and started experimenting with the data, but then I understood it's pretty messy, so I decided to create a new one, which is more structured and better for presentation. So let's use this one. So the objective is to classify images by category, gender, and color. And why these categories, you're gonna ask? Why these features? The point is that first of all, it's very convenient for users to filter out by these features when they search for items. That's why it's a crucial type of features. And also the second reason is that the public dataset that I found is it has these features clearly defined in the columns. So that's just very convenient for the labeled data training, and that's why I classify by them. So for the models, I'm gonna try to train and compare 4 models for the same task, basically, which is classifying images. And for this purpose, I'm gonna use convolutional neural networks. So I'm gonna try to build custom from scratch. I'm gonna use the ResNet 18, EfficientNet B0, and Vision Transformer. So let's start. In the beginning, I have some imports for the libraries that I'm going to use in this notebook. Then I also have some setup for the folders and files that I use as a dataset. So the dataset that I found online, I've downloaded it and has it here. So I have styles.csv file, which has columns like ID, gender, master category, subcategory, article type, base cover, season, year usage, and product display name. So how it works, the ID of the item is basically the name of the file of the image. So I have images folder here, and you can see that I have images which are just called with numbers. So this kind of image, right, or this one. And that's how I'm gonna map the images with the data here. So, okay, let's inspect the data. I'm just investigating what's happening with the data that I have here. So again, columns, I already showed you some more information about the columns. I have around 4,424 items here. Then I'm gonna remove the columns that I don't need for my classification, like I mean all of the columns I don't need except from gender, master category, and base color and ID. So I remove all other columns. I see the distribution of the values for category, for gender, and color. Then I'm gonna clean the data for my needs. So the first thing I'm gonna do is keep only relevant categories, which are apparel, accessories, and footwear. So I don't need any other categories, so I'm just gonna drop those items. And also I don't need boys and girls items, so I'm gonna use men, women, unisex. So after remove the category, also I wanna change the name of footwear to shoes, because just to align with my database for Fitfolio. So these are some numbers I have for these columns. Also, I'm gonna map the colors into 12 base colors that I use in Fitfolio. So, like for example, I don't need navy blue. It's basically gonna be just blue. And after mapping, so I left with metallic and multi. I searched for these colors and they are pretty ambiguous, so I just dropped the items with these colors. It's not many, so it doesn't affect the training of the models. Nice, I don't have any other colors left, and now I'm gonna create a new column for the image path to match the items with images. So you can see that I have now image path column here, and some of the items didn't have the images in the folder, so I removed them. And now let's split our data to train and validation sets. So first of all, I'm gonna convert the string values for categories, gender, and colors to integers, because it's more efficient, and that's how we use how we train models in machine learning. Right, so these are the the columns and the values that are left here, and I'm creating the label columns for category, gender, and color. Then I'm splitting the data into training and testing splits. I'm using 70-30 division. Then I verify how I split the data. So it's pretty much even. You can see here based on the percentage. Then I do the same with gender and colors. So let's go next for the dataset. Again, as I'm gonna use and I'm gonna train different models require different inputs, so I'm gonna transform my inputs to match the models. And for the basic model I have here, I'm gonna use these transforms to and resize image to 224 by 224 and to tensor. So here I define my data set. I use it so that the image is loaded on the disk and can be seen by the model. Again, I use this class for getting the train and validation dataset with the images. And so I inspect the size, which is right for the model. And then I put these datasets into the data loaders, which are basically used for faster model training. I put batch size 32 so that the 32 images are processed and analyzed at a time and shuffled through so that images are not in the same order for the model each epoch, so that they are randomized. And let's go to our first model, which is a custom model from scratch. So we have here like feature extractor layer, we have the shared representation layer, and task specific heads for our needs, like for categories, genders, and colors. So representation of the model, training setup. So I define cross entropy loss for the tasks. I put the optimizer. I have the training function here, the evaluation function, and then I train for 5 epochs. So the results that I got, you can see here. I mean, the accuracy is for categories is 0.92, for gender is 0.73, for color is 0.67. But again, we will we'll compare all the results later. So we can see that the custom model provides strong baseline results, but I think we can do better. So let's go to the model B, which is ResNet 18. So basically, again, I transformed the input so that it matches the model. Again, I do the same for getting the datasets for the ResNet model. And here I import this model and the weights and provide a basic structure, and eventually also train for 5 epochs, also get the results, and they are slightly better, or you can say like they are better. Again, we'll discuss later, so let's go to model C. Again, pretty similar tasks. Model structure, again, train for 5 epochs, and the results here. And the last model is vision transformer, and this one was very long to train. It was around 70 minutes, but okay, I mean, we'll see the results and we'll compare all these factors. So I import the model, I provide a basic structure, tuning with our heads for categories, genders, colors, and training for 5 epochs, and the results here. So we can see that Vision Transformer achieved strong results across all 3 tasks and performed competitively with CNN-based transfer learning models. However, its accuracy gains over ResNet 18 were small, and it doesn't basically, it's not worth it. Considering how long it takes to train this model and how complex it is. So we'll go to the model comparison. What I have here. So I import classification report. I have a function to evaluate all the 4 models that I have here, and I run it, and for example, I have accuracy of 0.67 for the first model, then I have accuracy 0.21 for the second model, and 0.21 for the third model, and 0.77 for the fourth model. And you could ask me why so low accuracies for the two models in between them. And the point is, I made a mistake. I used the same orders for all the models, but there are different orders for different models, and that's why I used them before. So I repeated the testing. I also included the confusion matrix, and I got something like this. You can see the results here, and right away the accuracy for the first model is the same, but the accuracy for the ResNet, for example, is 0.75, and for efficient net is 0.77, and for the last model is 0.77 as well. We also have precision here, which is basically shows how much of the predicted values by the model are true, and we have recall here, which identifies how much of the true values the model could find, basically, and F1 score, which balances these values. So overall, accuracy comparison across models shows a clear improvement when using transfer learning approaches. When we're having 0.67 accuracy for our first model, and 0.75 for ResNet, and 0.77 for efficient net and vision transformer. So transfer learning significantly improves performance of the baseline model. Efficient net and vision transformer achieve the highest accuracy of 77%. ResNet 18 provides a strong balance between performance and computational cost, and simple CNN performs noticeably worse, indicating limited feature extraction capability. Overall, we have some problems with some colors, like for example, we have low precision and recall on beige. It's confused with white, brown, and yellow. Also, we have problems with orange, like it has lowest recall across models. It confused with red and brown. The point is we also have small sample size of this color. And some comparisons, I think we already got it. So some important factors affecting the performance. First is class imbalance, like overall. For example, orange is 171 samples, and for black we have 2,816 samples, which leads to bias toward dominant classes. Color ambiguity, for example, we have classes like beige and gray, and they overlap with others, and they hard even for advanced models to separate. Label quality, some possible inconsistencies, and maybe it adds some noise to training. So overall, we can say that the best model is efficient net B0, and but the best practical model would be ResNet 18. The vision transformer is strong performance, but it's not efficient for this task. So now we're going to use the ResNet 18 as our main model based on this evaluation. Also, what I did here is some table, but I wanted to try to improve the ResNet 18 based on the problems we got here and analyzed. So let's go to this section where I tried to improve the ResNet 18. So the objective is to keep the original model result as a baseline to compare, then improve the color task with class weighing, increase the importance of color loss in the multitask loss, review augmentation to make sure they do not distort color information, fine-tune more backbone layers with a smaller learning rate, and compare improved ResNet 18 against the original ResNet 18. So I compute color class weights. I encode color labels from training set. Again, compute balance weights and convert to tensor for PyTorch. Then I have the pre-trained ResNet here. Basically, it's similar structure as we did before, but then in the cross entropy loss for colors, I put the weight equal to color class weights that I calculated above, which I suppose would be beneficial for the model. And also I put the optimizer Adam so that it learns better. So again, training function, evaluating function, and I feed the model and trained for 5 epochs again. And you can see that I actually didn't get much better compared to the previous model. So next I want to test whether the issue is that the color is under-prioritized in multitask learning. So I trained the model again for epochs, and the result wasn't really different. So the overall opinion is that the baseline ResNet 18 model is pretty much efficient and good for the further usage. Next thing I want to do is reject image based on confidence. That means that, for example, the user would submit an image of a cat or a dog, and the system would not allow them to do this and would decline their image. So for that means I use it based on the confidence. So I have a threshold here, and let's see real examples. So I tried to create a function, but something went wrong here, and essentially I fixed it. And for example, now I could load image from my data. Let's see. Portfolio data, item 2. So I have here this image with the blue sweatshirt, and again it identifies the apparel, man, and blue. So the item, the model works on our items. I also did some more with item 3. This one, and it says apparel, man, wage. Item 4, I mean, it's pretty much the same. Item 5, we have here the woman in red items, and it identifies the apparel, women, and red color. So next I did is to introduce confidence. I displayed here, and threshold is 0.6. So if the confidence is more, so I do not reject, right? Not reject. And here I use the item 6 image, which is the cat. So the model, the threshold 0.6, right? And the model rejects it. Then I had item 7, which is this dog in the jacket. But as I remember, the model didn't reject this one. So after that, I decided that I should increase the confidence, because the images with items already get like more than 0.90 confidence, and to increase the threshold up to 0.70 is pretty much okay. And the next thing I wanted to do is removing the ground from images, so which would be also beneficial for the models to analyze them. So I did some testing here, and for the test items set, which is this one, I have the item 21. So it's this one item, this shorts on the with the ocean and sand in the background, and I'm using this kind of model to remove the background, and the removed background image is this one, and you can see that it pretty good result for the background removal function. So this one is okay, and after that I had to run code for putting all the for classifying the images, some of the images that I chose. I tried to use images from different genders, from different categories, so that to kind of overlap all the possible options for the images. And these ones are here. So I have shoes, I have this one, I have some women clothing, high heels, so absolutely different items, and I wanted to put them through our model to classify them with the gender, category, and colors. And then I saved it to the CSV file, which I used later for the enrichment pipeline. Next, for the means of evaluating the models for item enrichment with meta tags, I had to create a dataset of ground truth, and for those means I basically used the dataset that I got from the previous Python notebook and applied those items with images to the GPT for all, just for initial seeding, and then I manually adjusted the meta tags and the categories that I got. So this is all the stuff I have here. This is the prompt I used. So the point is I have master category and have subcategories. So I provided a list of subcategories for him. And also for the meta tags, I have 7 columns like themes, occasions, vibes, styles, aesthetic, fit, season, function, and I provided the limited sets of values for these meta tags and asked him to provide 1 to 3 values for from these meta tags, for these columns. Overall, that's how I seeded the initial data. So this is the process. And then I adjusted it myself. So I had a data set of ground truth, and then I started testing. So I tested again with GPT for all, and then I tried to do other models. So I saved all the results for the model enrichment in their appropriate files. Also, I have model outputs folder, and basically I used GPT for all, GPT for one, and GPT for all mini, and also I tried Gemini 2.5. And this notebook is all about this. I had some issues with this, with the API keys in the first place, but then I figured it out. So these are 4 models that I use. I just was curious how different the results are, because some models are more expensive, some are cheaper, and is there a difference? Is it worth to use the more expensive model or no? So I ran all the models and saved the results in these files. So I have JSON, I have CSV, Gemini 2.5, GPT 4.1, GPT for all mini, and GPT for all. And then I had a file for comparing those results. And so here I have a Python notebook for comparing the results of these models. So basically, my idea is to compare the subcategories of the resulted so here I have the Python notebook for the comparison of the results of these models. Basically, I compare the results to the ground truth dataset. And what I do is compare the subcategories if they exactly match the subcategories in the ground truth dataset. And for meta tags, I use F1 score to see how much they are the same, how much they overlap, or maybe they are exactly the same or they're different. And all this notebook is about this. And finally, I get some results like this. I did some little statistical analysis, and we can see that GPT for all mini performs slightly better than all the others. Overall, they are all good, but it does it better. The reason could be that it has more strict rules, more focused. It's more focus based, and that's why it can be better in such a strict task like defining the categories and meta tags. So this is a good way to this is a good reason to basically choose this model for our means. So now I would like to show you how I use the model that I trained in the endpoint. Unfortunately, I wasn't able to implement the full item enrichment process because I didn't have enough time, but I can show you how I use the model. So first of all, here I export the model that we trained, and then, so I have it, let me call this. So I have the model in here with label classes, and then, for example, in my main file, I have the endpoint for classify item image with the input for image, and I check if the model is not loaded. If it's loaded, then I continue, and I put the image to the model. I have some check for the image, and then I put it in the model. As a result, I get, let me show you. So I get these values as a result after classifying. So I think we can test this. So I have the dataset here. For example, item 1, I think I have my server running. So we can try to use this curl function. And I have shoes, category shoes, gender man, color white. That's correct for these shoes. Let's try this one, pink shirt. It's item 17. So I have category apparel, gender man, color pink, which is correct. And let's try this hat, item 12, the last one. So category accessories, gender women, color black, and that's correct. So that was all for my part. Thank you very much for watching the demo video. If you had any questions, I would willing to discuss them if it is required to schedule a meeting. But overall, thank you very much, and bye-bye. Have a great end of semester.